uses sound waves to levitate and manipulate objects for touch-free building. We spoke to one of the researchers behind LeviPrint to learn more about how it works, what it's capable of, and how it could be put to use. Let's check it out.
LeviPrint is a system that can levitate, manipulate different objects to assemble complex pieces. Of course, these objects could be small spheres, but also droplets of glue, and cure it whenever we want with ultraviolet. And the most important thing and the most novel thing is that we can levitate, move, and rotate sticks.
The levitation is created by sound waves that have a frequency approximately double the highest frequency that we humans can hear.
When you create these sound fields, they have different shapes. Yeah, they usually have like a wavy pattern. And when you put small objects, they get trapped in this standing wave.
In LeviPrint's video, you can see the interference patterns created by the sound waves.
Dark areas like black, it's like low amplitude, or if we talk about sound, low volume. Areas that are brighter, that's high intensity. And you can see that the particles, they tend to go to the low amplitude areas.
These low amplitude areas are good for trapping and manipulating objects like spheres or glue droplets, but when elongated objects like sticks get involved, it gets more complicated.
When you levitate small particles or a droplet of glue, it looks like a pair of fingers. It holds the particle there. But when we levitate sticks, we tested different methods, and some fields, they look like two pairs of fingers. Others look like if you were like holding like a sandwich. But the one that worked the best were like having like two traps at the sides of the stick. Not exactly at the sides, but with an offset of 1 millimeter or something like that.
The video released by LeviPrint shows the device using sticks, spheres, and UV curable glue droplets to build a variety of different shapes, structures, and this orange cat thing? But why might someone want to build using acoustic levitation rather than, say, another method?
There are mainly three advantages of using acoustic levitation to assemble objects. A robot twister could hold something, but then if it's going to hold another material, another part, maybe you need to change the twister, or otherwise you will cross-contaminate the pieces. So acoustic levitation is cool because it minimizes cross-contamination. Another advantage is that with the same levitator, with the same end effector, you can manipulate a variety of things. You can manipulate sticks, you can manipulate particles, you can manipulate glue, and you don't need to swap let's say the holder. And the third one is you can move these parts through holes and cavities.
Asier tells me that this LeviPrint technology could be useful in the biomedical field where they're worried about cross-contamination, or in manufacturing things like watches or phone cameras due to their small and sensitive parts. But it'll probably be a while before we see anything like LeviPrint being used commercially.
Maybe for calling it a 3D printer, it would need to be a more developed prototype. Yeah, like there is a process, a system that we give to somebody and they know how to put their 3D model. There will be a software that will slice it or calculate or divide it into parts and then plan the levitation of those parts, and then the system will assemble this object. And so far, okay, we have some working principles for that, some basic pieces to achieve that, but it still would need more software and engineering.